Okay, so today let's actually try to implement one of these kernel linked lists things from scratch so that we can actually understand what the heck the kernel is trying to do when it does use these linked lists, since it's kind of different from how we normally do linked lists in our own coding. Gonna do it in a different project, not in the kernel, because if I were to do it in the kernel, I'd get completely lost. It is harder than a normal linked list, so we're gonna take our time and build it up one by one, piece by piece, and then see where we go from there. Okay, so we're back in our directory of little C projects. We're just gonna create a new one, uh, and just in VS Code this time, just write our own version of the kernel linked list. So I'm just gonna make a new directory, make dir kernel linked list, like this, and then I'm just going to then go to VS Code. Should have it somewhere here. If I would refresh here, refresh kernel linked list. Where is it? Right here. I'll just create a new file, main.c, and just do our usual template, which is going to be include stdio.h, and then we're going to have int main, and we're going to return 0, and we're just going to have hello world. New line. Okay. Yeah, let's do that. And then let's just compile. So gcc main.c, a.out. Great. Good first start. Okay. So normally, when we deal with linked lists, we have this recursive structure where, let's say, we defined a person struct, for example. So we do struct person, and then we'll give it maybe like a first name and last name. So every person has a first name and last name and some sort of age. And in order to be able to link these persons together, we usually have like a reference, a pointer to another person struct. So something like this, struct person next, like that. Okay, and that's like the normal way of kind of defining a basic linkable structure. So it's still person struct, but the fact that it has that pointer to a person struct called next allows you to kind of link a person to another person to another person. So how that looks like is something like this, where you have, let's say, person here. Okay, let me just make this a little thicker. Okay, so you have a person here, and then you have, let's say, their first name, and then you have their last name, and then you have their age, and you have next. Okay, and then that is a pointer. Okay, so you have this person here, and this next is actually pointing to another person. So this next actually points directly to this person structure. Okay, and then this next, let's just say, points to null. So how that actually looks like in memory is something like this. Wow, my pen game is kind of on point today. Okay, so maybe it's just because I'm doing this more often. Okay, so let's say this is a person. Let's say first name, age, and then this is maybe the start of the next person here. Okay, just pretend it goes on and on. And we'll have it, I don't know, maybe address 100, 101, 102, 103, 104, 105, 106, 107, so on. Okay, so this here is going to be first name, last name, age, next. This could be 88. This could be Russell. This could be Bill. And this next here could be 106. That's a memory address. So here is the start of another struct. Okay. First name. Why not Kobe? And then last name, Bryant. Okay. So this 106 points pretty much to the start right here. And that's how you go from person to person linked in this way. That's our normal way of doing it. Or at least the way that we're used to doing it, the recursive way. Let's see here. Okay. Now, let's actually write that in code. How we normally do that in code? Well, we can just do something like this. So let's say we wanted to create that Bill Russell, Kobe Bryant, and let's just introduce Michael Jordan too. Actually, that's a very guard heavy. Let's introduce a forward. We have a center, we have a guard. Let's introduce a legendary forward. Someone we actually like. Larry Bird. Yeah, Larry Bird. Let's do Larry Bird. Okay. So we'll do struct person. Okay, so pointer. And we'll say this one will be the head node. And we'll malloc size of struct person here. So we'll initialize one person. Let's just call this Bill. And we'll have another person here. We'll just call this Kobe. And we'll malloc that. Again, we want to allocate enough size to fit a person. And finally, we will have, what is it, Larry? Yeah, Larry. Okay, so we have these three, but they haven't been really initialized yet. So let's just initialize some stuff. So we'll have Bill, first name. Let's just create a new string with stirred up. And I think we can include string.h here. So we can just include stirred up, and then we'll just say Bill, because it's not a constant string. Okay, and then Bill's age is 88. Then we'll have Kobe, first name is going to be stirred up Kobe. Kobe, last name is going to be stirred up Bryant. And Kobe age is going to be 42. Finally, Larry. Larry, first name is going to be stirred up Larry. Larry, last name is going to be Bird. Bird. Larry, age. Don't even know how old he is. What is he, 70 now? Let's see. Larry Bird, age 68. Oh, okay. Sorry, Larry. Okay, 68 years old. Okay. So we have these three persons. What we want to do is be able to kind of create this type of structure, like this link. This is what we call a linked list of persons, right? So this is a linked list of persons. Okay, that's what we call it. Linked list of person, where a person has a next property. Okay, a person has a next property here that ends up pointing to another person. Okay? So, again, let's look at it like this. So, simplified version. blah, 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 next, points to person. Blah, 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 next, points to, no, let's just say person. Next, points to null. Okay? So notice how they always point to the person. Points to the person. Points to, starts. Okay? That's what we're trying to create here. That's like your normal linked list. So it's as easy as this. It's just Bill. Next. It's going to be Kobe. Kobe. Next is going to be Larry. And then Larry next is going to be none. Okay, and we can traverse through this list by saying, well, okay, let's declare a struct person pointer t to be Bill. That's our head. And then we have a while loop while t is not equal to null. We can just simply print their information. Like this. T, first name, T, last name, and then TH. And then we move T to the next thing. Okay? And so if we compile that, oops. Oh, stdlib. We need stdlib. Okay, stdlib. Compile again. Okay, so Bill Russell is 88 years old, Kobe Bryant is 42, Larry Bird is 68 years old. Easy enough. Normal way to do linked lists. Okay, so how does the kernel do it now? Kernel does the linked list differently. So kernel defines a new struct called list head. Okay, where it has two pointers. We'll have a pointer, pointer to a list head called next, and then a pointer to a list head called prev. Okay, so why is that? That is a doubly linked list. And the kernel also makes it circular. But that's not the important for what we're trying to learn. So to simplify things today, we're going to make a variation of a list head that only has a pointer to next. So this is a singly linked list. So this is what we want. Okay. Today we're going to go over it this way just to simplify things. Now, how does that look like? So, at this point, let's say we define this in our code. We'll say, well, let's have a struct list head. And this will just contain a pointer to next. Okay? We then remove this one here and just leave it be for now. So we'll just allocate a bunch of this stuff here. Leave that there, get rid of this. So we're cleaning up now. Okay. So at this point, we have two different structs. They are disjointed. They have no relation with each other. It's just a list head and a person. So really, they're separate things. You'll have, let's say, pretend this is the heap. This whole thing is a heap here. So basically, you'll have a bunch of list heads. And then you'll have person. They are totally separate things at this moment in time. You'll probably have another list head here. Then maybe a person here. And then maybe another list head here in memory. Okay. Person and list head again are totally separate. They only start to relate when you actually bring in now adding a new property in person, a list head. And the kernel, the book, will define a property of list head type called list. Why is that? Because really a person is supposed to contain a linked list. So we're no longer having a person point to the next person. We're just having a person contain a linked list where these linked lists are pointing to other list head types, this list head objects. So this list is not really pointing to the next person. It's actually pointing to a list head where it has its own property that points to the next list head. How that looks like is going to be something like this. So now that we've introduced list head into person, we can say a person now has a first name, a last name, age, and then a list, which is a pointer. Okay? So that's one. Let's have another one. Person. I have a first name again. We'll have a last name. We'll have an age. And then we'll have a list again. Just to hammer in the point, we have another person. Our first name. Last name. Age. Then we'll have a list again. Okay. Alrighty. Okay, how does this work? So it's actually not, this list here is actually not pointing to person at all. Okay, it's not this type of movement at this point anymore. It's actually going to be list will point to list with next. So it's next pointer. Okay. Now here, its next pointer is going to point to this guy. So it's next. And then this next is going to point to null. Okay. So every single list property in the person struct is not going to point to a person, but it's going to point to a list struct value. Okay. So now you might be asking, how does that actually look like in memory? So we can do it like this. Let's just do 2, just for an example. $100, $101, $102, $103, $104, $105, $106, $107, $108. There we go. So we'll just give this one, I don't know, first name is going to be Bill. Last name, Russell. Age, 88. Then we're going to have a list structure that only has a next. Okay? And that's a pointer. That's how the struct would look like. And then we'll just highlight this in blue. Okay? Then we'll have another one, let's say right here. Kobe. Last name will be Bryant. Then age will be 42. and then its next pointer, I don't know, it's going to be like, so this one's going to be 108. So pointing effectively from here to down here. And then this one, I'm just going to make it up and say it's 115. Highlight that in red. And that'll point somewhere down here. Okay. So the question now you're probably asking, okay, well, if this list head next is just pointing to another list head next down here, how? Okay. So how do we find the person associated with list? Okay, so that's the burning question. So given, let's say we have a list head here, so our list head here, okay, how do we actually find that this list head is actually contained by this person, Kobe Bryant here? The answer is a macro that the Linux kernel has called container of. And it gets 3 args. Okay, the first one is going to be the pointer to the list head. So pointer. Next is the type of the struct containing the list head. In this case, we want to find the person, so struct person. And remember, macros are not valid C. Finally, the member of where this list head this list head exists in the type. So container of, and that is in the kernel code. It's defined as a macro somewhere. I think we read it in the book. The macro is this one right here, this container of. So given these 3 arguments, it replaces this call container of with this piece of code here. So type is struct person, for example. Member is going to be like list. So it does all this math here to determine like offsetting, like given the member list, doing some math, subtraction to where that person struct starts, and return that pointer. Return that pointer to where that person struct starts. Okay, so now that we have a member called list here, like an attribute is value inside person, we can start to create a bunch of list head objects and assign it to that list struct. Okay, so in this case, let's create 3 of them. So again, there are 2 like independent structs. So the reason why is that the kernel is trying to be generic, where you can reuse this list head to create any type of linked lists, where that wasn't actually possible before with having that recursive struct where we had like a next pointer pointing to the next struct of that same type, and so on. That would, like, creating different types of linked lists would cause you to have to define new structs with that. But with the struct list head, you can just inject that as another member to a struct, and then you can have this generic code where you just need to do this container of to find this actual node that is containing this list head. So in order to do that, we need to create separate list head objects and link those together instead, and then assign those pointers of those lists, or at least those values, dereferenced by those pointers, into the person struct. So I'll show you how to do that. So it's going to be struct list head, and it will say this is going to be Bill Bill list, maybe Bill list. So we'll do malloc size of struct list head. Okay, so to allocate some memory, it's just going to be 8 bytes really. 8 bytes for the pointer, 8 bytes for that pointer to next. So we'll do also Kobe list malloc size of struct list head. Then we'll do struct list head. What is it? Larry list malloc size of struct list head. Okay, so now instead of linking persons together, we're going to be linking list heads together. So we'll just do something like Bill list next is going to be Kobe list. Kobe list next is going to be Larry list. And then Larry list next is going to be null. So same thing. We were doing the same thing as before, except that we're working with the list head and not the person structure. So now what we want to do is we're just going to assign the members, right? Like Bill list is going to dereference the Bill list pointer to get that value, since we defined it as a value here. Reason why we left that as a value is because it needs to be like inside that struct. So similar to how they did it here somewhere. Where is it? Right here. Struct Fox, right? We'll just have a struct list head value list. So we'll do the same thing here. We'll just assign Bill list. That's a value, so we'll dereference Bill list like this. Same thing for Kobe. So Kobe here, we'll dereference Kobe list, and then what is it? Larry list can be Larry list like that. Okay, debatable. We could just use these as values, but whatever. I don't think they need to be. I don't think these need to be allocated in the heap or anything like that. So. Anyway, so now, what is this? I never deleted it. That's weird. Okay, so now what we want to do is, now that all of them have a list that where we can just go into and then traverse down by next, we need to actually test to see if we can get the containing person struct given some sort of list pointer, right? So let's copy over that macro that the kernel has called container of, and let's experiment, see if we can, like, given some sort of list head object, can we actually get the pointer back to the appropriate person? So if we were to look at container of here, this is email. Okay, we'll just copy and paste this straight up. And we'll just paste as plain text like that. Now we can use container of, and it'll be replaced by this code here. So how do we use this? Again, pointer is the pointer to the list head inside that struct, inside the person struct. And then type is going to be the struct person type. Member is going to be the name of where that list head is inside that person struct, or the person struct's declaration right here. Okay, so and it returns back a pointer. It returns back a pointer. So if we were to say something like this, okay, struct should person pointer should be Larry. Okay, if we were to do container of, for example, we would need to pass in, well, Larry list Okay, and that's a pointer, so we need to get the address of Larry list, because list here is a value type. Then we also need the definition or the declaration type, struct person. Okay, and finally the member name inside that struct person. So this should get us, given this pointer to Larry list, okay, it should actually give us back Larry Bird, the person. So hopefully it works. So if I did printf s d years old, new line, should be Larry, first name should be Larry, last name should be Larry, age. That should give us Larry Bird, given this list here. Okay, so let's compile and run. Okay, so we need to include stdef for this offset of thing here. So let's just include that and compile again. So okay, and yeah, okay, so clear. One more time. Good. Okay, so then we get back Larry Bird, 68 years old. So that's a good thing. So we're on the right track here. We have the right mindset. We have the right mindset. We basically did this here, where we're only caring about the list head, and we're leveraging container of to get back the exact person struct it corresponds to. So in memory, given this this one here, for example, we use container of to actually get the pointer here, 105, and so then we could just start accessing values that way. Right, now that we have the normal like lists defined, like where each of these list properties link back to another list, I've rewritten this to be simpler, where we just actually pass in the struct values directly and using the struct initializer. And I just link them all manually this way by saying, okay, well, Bill's lists dot next is going to be the address of wherever Kobe's list is. So then that still gets the equivalent thing. So now what we want to do is we want to actually iterate through this list head, not the person, but the list head, so that we can actually find the person associated with it. So equivalently, it's going to be something like this list for each macro, but we're not going to look at that macro. We're going to try and code this by hand. So what I'm going to do is I'm going to have that same print statement as earlier, but I'm going to define a function that does that. So I'm going to do void print list. I'm going to struct list head, and that will be just taking in a head pointer, basically the start of the list. Same as always, I'll just have some sort of pointer that is initialized to the head of the list. So this is like a normal linked list traversal at this point. And I'm just doing while t is not equal to null. I'm just going to then have this scaffolding code where I just iterate through the list, but at the same time, I want to actually take and grab that person associated with it. So cur person. And again, I use the container of macro to get what I want. So in this case, it's going to be t is the pointer. Then type is going to be struct person, and then the member inside the struct person is going to be list in this case. Okay. And then I just want to print again the same thing I did last time, which is going to be the first name, last name, age. Years old, and use the current person pointer to get that piece of data. Sorry, I'm getting kind of lost in my own code again. And finally age. Okay, so how we use this is, well, now let's go down here and call that function. So print list. We're going to pass in the address to the bill list, because that's, again, its pointer. This takes in a pointer, but this is actually a value. Okay, and then this will already pre-did this, so okay, so we got the equivalent effects. All right, so that's like the basic movement of it. It's just like any other linked list, except that you're not really dealing with the person struct itself. You're dealing with list head objects at this point. Yeah, that's all I can say. Like, I think we should at least like clean up stuff, right? So we can just do this. What is it? Free. Actually, let's create a function of free the person. So void free person, struct person pointer, and then we can say free person p. First name, free p last name, free p, we don't need to do that, and then we're just free p. We didn't allocate, but these are values, so okay, and then we just do, hopefully this works, free person Bill, free person Toby, free person Larry. Okay. So yeah, basic movement. And I think from here you can just modify what the person is, and we can just do your like typical linked list operations. Let's see if I broke anything. Oh, it looks good. So it would have errored out if or something. So actually, val grind leak check equals full. Okay, let's see. Let's see. Oops. Oh. Sudo pacman sy val grind. Okay. Is it doing anything? Okay, yeah. Keep summary. Zero in use is 0 bytes. So all heap blocks are free, no leaks are possible. So we did the right thing here. Anyway, next time, let's move on. I just wanted to show you how to think about these linked lists. It's not too bad. Just remember that we had to make use of these macros here. Think in terms of list heads, not the struct, not like the specific data type we're thinking about. And everything should be straightforward from there as long as you're disciplined in using some of these provided macros here. So, yeah, that's it. Thank you.